Hello, my name is Alvin, and this project is called ARLA, which stands for Augmented Reality Learning Assistant. And what this is it's an educational mobile application that's designed to help students learn algebra, mathematics as a whole, but this prototype is focused on algebra. And it helps them learn algebra through interaction rather than relying on traditional equation solvers, for example. So the main problem slash motivation to build this app is because algebra is often very difficult for students because it's a lot of abstract concepts. What ARLA does is it addresses this by requiring students to perform each algebraic step by themselves while the system validates their reasoning, and it also provides feedback. The goal isn't to give answers, but to support the conceptual understanding. It does that with the app itself, which has AR integrated into it, hence the augmented reality. Um, okay, so the reason that I chose augmented reality, or the reason that it's central to this project is because algebraic concepts such as variables, constants, balance, they are represented as spatial objects. So it makes the idea of equality more intuitive rather than, again, abstract. AR allows these abstract ideas to exist in the student's physical environment, which supports a deeper understanding. Okay, so now to the Figma prototype. So when the user opens the app, they're guided into the learn mode by default. So right over here, start learning, there are two modes, the learning mode and the practice mode. They're essentially identical, but they serve different purposes, which I will elaborate on. So once the user opens the app, they're guided into the learn mode. So they click this, and before entering the AR experience, the student answers a short pre-question. That's what I've decided to name it. And the question essentially measures the baseline understanding of the correct algebraic process. So for example, over here, 2x plus 3 is equals to 11. That's the first step. So the student who try and answer correctly, they click the option. Once it's been selected, we click continue. The app validates it. So the question is repeated again. It gives kind of the validation over here and also any tips, any kind of just a laid out explanation of what the student is doing. And then they continue to the next one. This is not the final answer. So over here, this is what kind of emphasizes the student doing it themselves. So they click the correct thing, which here I believe is subtract. We go to continue. You can see that it's given in the example. We click continue. If it's correct, it says it's correct. We come to continue, the same thing again, but for the next step. So we come here, we click divide, and then we click continue. After it's been solved, so after the student has solved the equation and we've kind of measured the pre-question phase, what you're taken to next is the AR aspect of the application. So the interface is going to represent the balance of the equation. So we'll be using AR to show a balance scale, and the blocks that are going to be spawned are going to represent the equation themselves, and it's going to be anchored to like the real world surface. This is going to be done using the AR foundation and AR core. So the students have to choose the algebraic operations themselves. So the correct actions are immediately confirmed, while the incorrect ones trigger feedback. This ensures that the app functions as a learning tool and not as a solver. So after the student has done all of this, going through the question themselves as well as the AR part of the questions, the main focus of this app is to kind of measure the learning outcomes. And the way this is done is by looking at the student's performance before and after the interaction, and also look at the ability to complete the solution independently. And this gives us a good idea of how much impact that ARLA, aka the app, had on the students' learning. So this prototype just demonstrates the learning logic, the interaction flow, as well as the AR intent behind ARLA, and it serves as a foundation for the full AR implementation in Unity. Thank you very much.